So with this learning goal, we want to go from an acceleration time graph to a velocity time graph. So given an acceleration time graph, I can graph a velocity versus time graph. So let's look what happens if we take the area of this graph. Let's just see what will happen. So area is length times width. For this, it's a square, a rectangle. My length is going to be my change in my time, and my width is going to be my acceleration. So if we notice, I'll write this on the side, our definition of acceleration is our change in velocity or a change in speed over a change in time. So if we rearrange this equation, let's rearrange it and multiply both sides by time. These two will cancel, and what I'm left with is change in velocity is time times acceleration. So let's look what we have here. Well, that's just what we have left over here. So I can say my area is just my change in velocity. My change, that's the key. So in this case, my area, well, let's use an example here. Area is length times width, which is 2 seconds times my width is 2 meters per second squared. You'll see that the units are going to cancel them. What I'm left with is 4 meters per second. So this tells me my change in velocity. This is my change in velocity. So for these graphs, we're going to assume that, or it would have to tell you what the velocity starts with. So for this graph, let's add on to the question, assume the initial velocity, or let me write that, initial velocity. Is 0. So if we assume the initial velocity is 0, my change in my velocity, which was my area, is 4 meters per second. Meaning after 2 seconds, my change in velocity, I start at 0, I go up to 4 meters per second. Now, I'm going to draw a straight line here, and let's talk about why I'm going to draw a straight line in a second. We learned how to go from this graph to this graph, and we said take the slope. And if the slope is constant, we'll have a constant acceleration. So if I have a constant acceleration, that means I'm going to have a constant slope. Okay, good. So we've done it for this section. For this section, my area is 0. So if my area is 0, my change in my velocity is also 0. So from 2 to 3 seconds, I'm not changing my velocity. It's staying at 4 meters per second. Now for this last one, my area, I'm going to have to do it over here. Area is length times width, which is 1 second times -2 meters per second squared. My seconds cancel, I'm left with -2 meters per second. So now, from here, my velocity changes by -2 meters per second. So I started up here, I'm going to go down 2 meters per second to there. And that's all it is. So to generalize what we talked about, to go from what we just did today was from acceleration to velocity, right? Given an acceleration time graph, I can graph a velocity versus time graph. And we found that if we took the area of our acceleration graph, that gave us our change in velocity. So if I want to go from this graph to this graph, first I need to find my area. So from this graph to this graph, I need to find my area. Now recall from last week, to go from velocity to acceleration, I have to take my slope. This is true also from going from position to velocity. I need to take my slope. Lastly, to go from velocity to position, I take my area once again. So hopefully you can see the pattern that's going on here.